Let's take a look at section 1.5. Okay, throughout the year, we're going to look at all kinds of functions and how we can transform them. Okay, by transform, I mean move up and down, move left and right, or stretch up and down, stretch left and right. We can do it with all kinds of functions, but today we're just going to look at it with quadratics. Okay, so parabola type graphs. Okay, so a quadratic function has to be in this form. F of x or y equals ax squared plus bx plus c. And a, b, and c can be any real number that you want, except a can't be 0. Because if you made a 0, you'd wipe out the x squared term, right? You make a 0. Then all of a sudden you just have bx plus c. That's just a line. Right? So you can't have the coefficient of x squared be 0 in a quadratic function. Right, let's take a quick look at what y equals x squared looks like. This is the most basic quadratic function you can have. Okay. In this particular function, b is 0 and c is 0. And a is 1. If you make those substitutions I just said in what's up above, you get that. So let's look at this parabola. Okay, that's it. That's just your basic parabola. It's got a vertex, which we'll talk about in a second. It's the lowest point in this case, centered right at the origin. And I want to look at the difference between f of x and when you change x to a negative. Okay, that negative does do something. Let's see if we can tell what it does on here. So I'm going to change my x to a negative. Now, what happens when you square a negative? Yeah, you get a positive. So in this case, when I hit graph, the red line just traced right over the blue. It looks exactly the same. Okay, and the reason that it looks the same has to do with this line right here. The y-axis is a line of symmetry. Well, when you put a negative in for x, usually it takes the graph and it flips it. It flips it over the y-axis. But if the y-axis is a line of symmetry, when you flip it, you can't even tell you flipped it. Okay, let me show you one that you can tell it's been flipped. Okay, let me, let's take x plus 2 squared, and let's take, oops, negative x. Okay, same thing, except one has positive x, one has negative. Okay, and maybe you can see, if you remember from geometry, this is the blue one and the red one are reflections of each other over the y-axis. Okay? If you take the blue one, even if you just focus in on this top part, just look at this V shape. The blue line and the red line are reflections. Does everyone see that? Okay? So we couldn't see it before because of the symmetry. Okay, but we'll talk more about that later on too. Okay, on the parabola that I had before, it had a low point. Okay, we call that low point a vertex. Now, if you flip the parabola over, that low point could also become the high point, called the maximum. So whether your parabola has a minimum or a maximum, they're both called a vertex of the parabola. Okay, any questions on any of that so far? Sometimes this function y equals x squared, it's called the parent quadratic function because all other quadratic functions can come from this one. Everything else is basically a transformation of that. Moved up and down or stretched, different things. what I want to do is try graphing a couple and see if we can figure out what this number in front does. What happens when you change it from a 1 to a 1/3 to a 2? Okay, just try graphing. Anyone have a guess, or do you think they already know what it might do? Yeah?
Will it go wider or narrower?
Yep, it is going to stretch it. Let's check. Let's see if it stretches it more vertically or horizontally. So here's x squared. Here's 2x squared. Start with the standard window. Okay, so what we would say there is that 2x squared, the red one, it's been stretched vertically. Okay? Imagine keeping that point fixed right at the origin and pulling up on the sides of the blue one. Right? It would start to get skinnier if you stretched it vertically. Right? And let's also try 1/3 x. So let's put in 1/3. Okay, and compare these two. And what happened there is it's been compressed vertically. Okay, we could talk about it horizontally, but for certain reasons, you'll see why later. We're just going to talk about it as a vertical stretch or vertical compression. Yeah.
How did you type in the fraction?
I just put it as 1/3.
I know, but how do you?
Oh, how? Left parenthesis, division sign.
Oh, just.
Yeah, that's how you do the fraction.
Oh, I thought you pressed. I thought I saw you press a different button. So I'm like, oh wait, what? So you just.
You could also just type it in as x squared divided by 3. That'd be the same thing. Okay, so any questions on what that number in front did? So what do you think, how could we kind of generalize that? What do you think the rule is going to be? If the number is a certain value or higher, maybe it does this, or a certain value or lower, and it does that. What do you think that key number is going to be? Yeah?
With the coefficient, if the coefficient is greater than 1, it's going to be narrower. If it's less than 1, it's going to be wider.
Yeah. So if the coefficient is greater than 1, it's going to stretch the graph vertically, which makes it look narrower. If the coefficient is between 0 and 1, okay, like 1/3, 1/2, things like that, it's going to compress the graph vertically, which makes it look wider. So we'll think of it as a vertical stretch or a vertical compression. Okay, one of the two. Okay, any guess what's going to happen here? We talked about it a little bit, but not exactly like this. What do you think the negative is going to cause to happen? It's going to cause another transformation to happen besides stretching and compressing. Well, Dominic?
Would it flip?
Yeah.
Correctly?
Yeah, it's going to flip it. Okay, the only question is, how is it going to flip it? Is it going to flip it over the y-axis, or is it going to flip it over the x? Okay, let's try it. Okay, first, if you just want to see basic graph, I think that already tells you which way it flips it. Okay. Derek, which axis did that flip over?
Oh, I didn't graph actually.
Well, actually, you don't even need to. You can just look at that one.
It flipped it over the x-axis.
Yeah, this time it flipped over the x-axis. All right, so one of these graphs here, two things are happening. It's either being stretched or compressed vertically. And then the second thing is the negative would cause it to flip over the x-axis. Okay, so again, notice that the negative causes the graph to open downward. Okay, the parabola is opening down because it's been reflected over the x-axis. And you could try the other two. I don't think we need to. They look just like the other ones we had, except flipped. All right, so the next question basically is asking you how I could take the graph y equals x squared and change it into the graph negative 5x squared. Okay, there's two things I would have to do. What's the first thing I would have to do to change y equals x squared into y equals negative 5x squared? And think in terms of transformations. Stretching, reflecting, things like that. And start with the 5. How about Jen? What's the 5 going to do? Just the 5.
It's going to cause it to shrink.
Well, think back. Does if something bigger than 1 cause it to stretch or shrink? Yeah, it's going to stretch. All right, so the first thing that would happen to change y equals x squared into y equals negative 5x squared is a vertical stretch. Okay, we got to be a little more specific and say how much of a vertical stretch. So we just say vertical stretch by a factor of 5. In other words, all the y values become 5 times what they were in the original. Okay, and one more thing. So you do the vertical stretch. And last step, Ashley, what does that negative do?
So it's going to be flipped.
Yep, that's good. It's going to flip it or reflect it. And we just got to make sure we say which axis it's reflecting over. Which axis does this reflect over? The x or the y? Yep, it's going to reflect over the x-axis. So it takes something that looks like this and makes it look like that. Good. Okay, and that's it. So those are the two transformations that would turn y equals x squared into y equals negative 5x squared. Okay, now in this case, the order wouldn't matter. Okay, sometimes the order matters. It's kind of like PEMDAS. Okay, towards the end today, I'll give you the order. You should always write the transformations in. But if you accidentally switch these two this time, you would be okay. Okay, next part we haven't talked about yet. Adding or subtracting a number onto the end of the function. Does anybody have a guess what that's going to do? It's not going to stretch or compress it. That's what the number in front does. Yeah, John?
It's going to move it, the parabola is going to stay the same, but it's just going to move.
Yep, parabola is going to stay the same. It's just going to move. And when you put a number on at the end, we have two choices. Is that you think it's going to be up, down, or left, right?
So shift it left and right.
Left and right? All right, let's give it a shot and see. So just to compare, I'll graph x squared, then I'll graph x squared plus 2. So Aiden, you said you think left and right?
I was going to shift it up and down.
Here's the original.
Yeah, up and down.
Yeah.
I'm gonna think about it.
So it took it and it shifted it up. So minus is going to shift down. All right. So let's just write down these two things, okay? And then we'll go over the rules. Okay, so to get y equals x squared plus 2, just take y equals x squared and shift it up 2. Okay, to get y equals x squared minus 3, would take the parent function, the basic one, and you'd shift it down 3. Okay, so these are both examples of vertical shifts. Okay, a vertical shift is a rigid motion transformation, meaning it doesn't distort the parabola. It just takes what you have and it just moves it. No stretching at all. Okay, so if you have something of the form y equals x squared plus k, the way you get that, well, if k is greater than 0, take y equals x squared and you'd shift up. If k is less than 0, you take y equals x squared and shift down. Absolute value of k units. Why did I put absolute value in there? Or if I didn't put it in there, what would be kind of weird when you say this? Yeah?
If you're shifting down negative units, that should be shifting up.
Right.
Or you can just put shift up the units.
Yeah, so when we say shift up, that's straightforward. Shift up 2 units, okay? But when you say shift down, don't say shift down negative 3 units. That's kind of confusing. We just say we shift down 3 units, okay? The word down is the negative, okay? Down means that takes care of the negative. Okay. Any question on that idea? All right. Okay, so those are our vertical shifts. All right, so we've stretched and compressed vertically. We've shifted up and down. What do you think is going to happen here? You've got plus and minus, but this time it's in parentheses being squared. Yeah, Devin?
It's going to move to the left or right.
Yeah, this is going to move left and right. Which way do you think plus is going to move? To the right?
Or no, to the left.
You think plus is going to go towards the left? Okay. Anybody think plus is going to go towards the right? Some people? All right, let's try it. Let's start with the plus. Okay, we've got y equals x squared, and then do x plus 2 squared. Okay, so Devin said that's going to go to the left, and it does. All right, so this one's a little tricky. A lot of people see plus and they think plus goes towards the right because that's the positive direction. Well, when it's inside the parentheses like that, it's the opposite. In fact, any horizontal transformation, okay, whether it's to quadratics, whether it's to square roots, whether it's anything, the horizontal transformations always do the opposite of what you would expect. Okay, so that part you just have to remember. All right. So plus 2 is going to shift it left 2 units. Minus 3, that's going to shift it right 3 units. Just write that down. All right, so to get y equals x minus 3 squared, take y equals x squared and shift it right 3. Right, so to get y equals x plus 2 squared, okay, take your basic function and shift it left 2. Make sure on a test when I ask you for a shift that you're very specific. If you just said shift right and you didn't say how many units, you'd only get half credit for it. Okay, same thing if you said vertical stretch. If you didn't say how much of a vertical stretch, okay, by a factor of whatever, okay, you'd only get half credit. Okay, one thing I should probably mention, when you talk about the vertical stretch, I usually always say vertical stretch and I say by a factor of 2, 5, 1/2, 1/3. So if you say vertical stretch by a factor of a half, that's fine. It means it's really going to compress. All right? If you start using the word compress and stretch, I think it can get confusing. All right? So I always say vertical stretch by a factor of, just write down the number that's in front. That's it. Any question on that? All right. Okay, so horizontal shifts, again, another rigid motion transformation. Okay, and the idea is if you have a positive number, yeah. Okay, what I've done here is I've written it with a minus sign. All right, so another trick you can do is look for the number that's after the minus sign. Okay, the number after the minus sign here is a 3. Okay, if I ignore the minus sign, 3 is positive, it's going to shift it right. Here I don't have a minus sign, but how could you think of +2 with a negative? Yeah? You could think of it this way. X minus -2. Look at the number after the minus sign. It's negative. Negative goes left. So if that helps, you could also think of it that way. Look at the number after the minus sign. Ignore the minus sign. Look at what comes after it. If it's positive, go right. If it's negative, go left. Okay, it's a little confusing to think about at first, but I think once you kind of come up with a way to remember it for yourself, then it's not that bad. Okay, I'll use that idea a lot. Look at the number that comes after the minus sign. Okay, also, what's going to happen as we shift it, we're going to move the line of symmetry around and the vertex. Well, in this particular equation, the only thing that really affects where the vertex is going to go is the up and down shifting and left and right. Right? So normally your vertex is right at the origin. But if you shift it left and right and up and down, that's where the vertex goes. However much you shifted it left or right, and then however much you shifted it up or down. Okay. Since the line of symmetry is vertical, x equals is a vertical line, shifting up and down has nothing to do with the line of symmetry. Okay. It's only when you shift left or right, that's what changes the line of symmetry. So any questions on how the vertex or line of symmetry move when you transform a parabola? All right, so let's try this one. Okay, so all I want to know in this one, you don't have to graph it if you don't need to. Just want to know what the vertex is going to be and where the line of symmetry is. Anyone think they can tell me where the vertex is going to be? Okay, and be careful, especially with signs. Yeah, James? Okay, you're close. Do you see the difference inside the parentheses here? What's different about the sign here versus here? Yeah, this one's a positive. How could you rewrite it so it looks more like this, the negative? Anyone help him out? How could you write that instead of +2? So it kind of matches up more with what the formula is, and then we're going to focus on what's after the minus sign.
Minus -2?
Yeah. Let's think of it that way. Okay, because you always want to focus on what comes after the minus sign when you're inside the parentheses. All right, so John, what comes after the minus sign in this case?
-2.
-2. Perfect. So you've shifted left 2. And Ashley, how about the -3? What direction is that?
Right?
So this one, we've already done this. Actually, this is left 2.
Okay.
So the -3 is going to be,
Left.
no, left and right is just this number right here. This number is a different direction.
Down.
Down. Yeah, it's going to be down 3.
Eventually.
All right? So H, that controls everything that's going to happen left and right. K, that controls any movement translating up or down. Okay, and what about my line of symmetry? About Dave, where's my line of symmetry going to be?
-3.
So can you write it out for me, just like as an equation?
X equals -3? Or no, y equals -3.
No, I like x equals. That's good because it's a vertical line. So it's x equals. And which number should it be? The -3 or -2? -2. Okay, it's always x equals h. Okay, in this case, h, or what's inside the parentheses, is -2. Okay, so always use that trick. If it's written as a plus, rewrite it as a minus, and then look at the number that comes after the minus sign. Okay, this is another transformation one, and this time the order does matter. Okay, it's going to be 2 things you have to do. Anybody tell me what they think would be the first thing you would do to change f of x equals x squared into 5x squared plus 4? Which number do you think we're going to deal with first there, the 5 or the 4? Oh, Madison, what do you think? Which one?
5.
The 5, yeah. We're going to deal with the 5 first. Anybody tell me, what's that 5 going to do? Yeah. Yep, by how much?
5.
Yeah, it's going to do a vertical stretch by a factor of 5. Okay, so that's the first thing. And Autumn, what about the plus 4? What's that going to do?
That is going to move it up 4.
Yeah, it's going to shift it up 4. The only time you got to do that minus thing is if it's inside the parentheses. Okay? Otherwise, if it's outside, what you see is what you do. Okay? Vertical stretches, vertical shifts, exactly what you'd expect. Shift up 4. And you do have to do them in that order. Okay? If you didn't, it's kind of like not following PEMDAS. It's kind of like if I said, take a number and add 4 and multiply by 5. Or multiply by 5 first and then add 4. Okay? You're going to get different answers. You get different answers. Okay. Any question why those are the 2 steps? Vertical stretch by a factor of 5, shift up 4. Okay, this one. let's just start and see if we can figure out how many transformations we think there are to change y equals x squared into what's up above it. Okay, how many transformations do you think you got to do there? And one hint I'll give you is treat the negative and the 3 as separate. Those are two separate things. How about Jacob?
3.
3? Okay, go ahead. Tell me what you think. You don't have to tell me what they do, but tell me what you're looking at to figure out the 3 things.
It's just 2, isn't it?
No, more than that.
Oh, yeah, I missed the +4 on that. You'd have to,
So +4, that's one of them.
yeah, then the x minus 1. And
Minus
negative
1.
3.
And the 3 and the negative.
Yeah.
Yep, so there's going to be four things you have to do. Okay, and he just named each thing you need to look at. We just have to figure out what does what. Okay, and because we haven't done one with this many transformations, I'll give you a hint on how to start. Start inside the parentheses. Okay, so we'll start inside. Yeah.
-1.
Yep, what's that going to do?
That will shift it right.
Yep. Good. Look at the number after the minus sign. It's a positive 1. Shift right 1. Okay. Now the next thing we're going to do is what's right on the outside of the parentheses, the negative 3. Okay. Let's start with the 3. What's Keenan? What's the 3 going to do?
I want to say bring it left as 3.
So once we've done the horizontal shifting, nothing else is going to shift it horizontal. So your choices are either it's going to be vertical stretch, a reflection, or vertical shift up or down.
I'm sorry, I was a little distracted because it's still writing down past things that you already did. I just finished them. So I'm starting to catch up with you right now, actually. So yeah, it'd be, I want to say, vertical stretch.
Yeah, that's going to be a vertical stretch. Anytime you have a number in front, multiplied, okay, that's always a vertical stretch. Okay, in this case, by a factor of 3. Okay, the next thing is that negative. Okay, anybody remember what the negative specifically does? I'll give you a hint. It is a reflection. But let's see if we remember which axis, and if not, we can go back and look at the notes. Yeah.
Over the x.
Yep, it's going to reflect over the x. Good. And the very last thing on the end is a +4. How about Jen? What's the +4 going to do?
It's gonna move it up by 4.
Yep. It's going to shift up 4 units. Good. So a lot of, basically every transformation in that one problem. Okay, next thing they want to know is the vertex and the line of symmetry. If you've done your transformations correctly, the vertex is going to be easy to find. It was at 0, 0. What would happen if you were at 0, 0 and you went right 1, up 4? What point would you be at now? 1, 4. Okay, and your line of symmetry. It always starts out with which letter? Yep, x equals, because it's vertical. Okay, I might throw y equals on the test. Okay, that would be horizontal though. It's always x equals. And which transformation here affects the line of symmetry? Shifting horizontal or vertical? Horizontal. Yep. And it's been shifted right 1 unit. Okay, if you've got something that has a vertical line of symmetry and you shift it up, line of symmetry doesn't move. moving up and down doesn't affect line of symmetry. So that's the order that you generally want to do it in, and I think that's the order we did it in. You get your horizontal shifting, left or right, then your vertical stretching, then reflection over the x-axis if there's a negative. If there's no negative, you don't have to do that. And then the very last thing we always do is our vertical shifting, up or down. Okay? So that's the general order. And technically, some things can be switched, but if you follow this order, you're good. Okay. All the examples that we've done up until now have been written in a nice way. Okay? They've been written in a way that you can very easily and quickly identify the shift left or right, the vertical stretch, and the shift up or down. And if they're always written that way, great. That's called standard form. Well, sometimes it could be written the way you see it back in Algebra 1 when you're getting ready to factor a problem. Okay, and if it's written that way, it's like somebody did out the squaring and distributive property, they did it all out, then it's not in standard form. If it's not in standard form, we can't look at it and quickly see the shifts. Okay, like this one. 3x squared plus 12x minus 18. It's not written the way it has to be to see the transformations. So what we're going to do to change it so we can is complete the square. Okay, how many people remember how to complete the square? Okay, how many people at least remember hearing those words at some point? Okay, good. That's all I can hope for. So I'm not going to teach a whole lesson on completing the square. I'll show you how to do it in this problem. You might want to make a few notes, as I'm saying how to do it. All right, so we're going to complete the square with this equation. Y equals 3x squared plus 12x minus 18. And then we can describe the transformations. All right, first thing I like to do while I'm doing this is just, I like it with the 3x squared plus 12x minus 18 on the left. Okay, so I'm just going to kind of switch it around. 3x squared. And instead of putting equals y, okay, when you're completing the square, just put equals 0. Okay, we can change it back to y after, but for now, just put equals 0. Okay, so that's the first thing. Change y to 0. Okay, the next step is to move the constant to the other side. Okay, you have to do that. Move the constant to the other side. Okay, so I'm going to plus 18 to each side. Oops. Make sure you copy down your x. Okay, so I'll just write what I did. Move constant to other side. Okay, next thing. When you want to complete the square, the coefficient of x squared has to be a 1. So if you're lucky, the coefficient of both of these numbers, when you factor out what you need to, will come out nice. In this case, it will. What do I need to factor out from the two terms on the left to make the coefficient of x squared a 1? The 3. Yep. So factor out a 3. You're not factoring it out from what's on the right. We already moved the 18. Okay, you can forget about it for now. So make coefficient of x squared 1. If it's already a 1, you wouldn't have had to do that step. Okay, the next step. This is where we actually complete the square. So all I'm doing is I'm leaving a little room because I'm going to write something in here. Okay, and there's 2 steps to complete the square. Okay, we're going to add a number to both sides. But we got to figure out what that number is. Does anybody remember how you find the number to add to both sides? It's a 2-step, yeah?
Is it half of the b value?
Yep, good. Half of the coefficient of x. Take half of coefficient of x. And one more thing. What do you do with that?
Square it.
Good. You guys remember this. And square it. Okay, so in this case, not much interesting is going to happen. I take half of 4 and I get 2. And then I square 2 and I get 4. Okay, I just added 4 on the left. What do I need to add on the right? All right, I like the thinking. We got to keep it balanced. So you got to add something. But be careful. I didn't really add 4 on the left. What did I really add? Good. Why did I add 12?
Because of 3.
Right. Okay, so anything you have in these parentheses is really tripled. So you added 12 on the left. You need to add 12 on the right. That's the mistake people make all the time. Okay. Now, if we've done this correctly, this is going to factor very nicely. It factors as x plus 2, x plus 2. That's the whole point of completing the square. And now we just about have it in the format we want. Okay, last step. Bring 30 to the other side. And instead of putting 0, that's 0. Now you can put it back to y. All right, so now we can easily see what our transformations are. Okay, there's 3. Okay, the first one. Again, I'm going to think of this as what comes after the minus sign. I see -2. Which direction does that -2 shift it?
Right.
Left, right? Whatever comes after if you're going to do it that way, whatever comes after the minus sign, it's a negative. That's left 2. Okay, the next part is the 3. What's the 3 do? Yeah?
Vertical stretch.
Good, that's a vertical stretch by a factor of 3. If that number came out to a fraction, I would put vertical stretch by a factor of 1/3. Okay, if it came out to that, that's how I'd read it. And number 3, minus 30. Yep, it's going to shift down 30. So I can tell you where the vertex is going to be. -2, -30. Okay. Or if they just ask you for the vertex, okay, if that's all they want to know, they don't want to know the transformations, you can actually use this shortcut to find the vertex. If they want to know all the transformations, you got to go through completing the square. But if all they want is the vertex, this is kind of a shortcut formula you could use. I usually don't use it, but you could. A, B, and C, just fill them into those formulas. And last thing, zeros of a function. We've already talked about what zeros are. Okay, it's where the graph crosses the x-axis. And if you have a parabola, how many zeros could you have? What are the different possibilities if you draw a U shape? How many times could it cross the x-axis? Could do 2. Anything else?
Could do 0.
Could do 0. Yeah. So here's 2. Here's 0.
And 1.
And it could do 1. Just come down, kind of just barely touch it and go right back up. All right. So quadratics can have no solution, one solution, or two solutions. And very quickly you can check how many solutions it has just by using this formula, b squared minus 4ac. You probably remember that from the quadratic formula. This is the part that's under the square root. Right? If b squared minus 4ac comes out less than 0, there's no solution, because it would come out negative. And in the quadratic formula, you can't take the square root of a negative. If b squared minus 4ac comes out to exactly 0, you get one root. And if b squared minus 4ac comes out positive, you could get two solutions. So now if I give you an equation in that form, you can tell me how many times it's going to cross the x-axis just by plugging into this formula. You don't even need to sketch it. Any questions on that? It's homework tonight, just on one page. Okay, so not 2 pages tonight. This is page 56. And it kind of skips around a little bit. It's 1, 2, 7, 8, 10, 11, 16, and 18, 21 and 22, 28, 33, 40, 41, 44, and 60. Okay, I only did 1 page tonight because I think this material might have been a little bit newer, a little harder than some of the other stuff. So when we do that, we'll just stick to one section a day.